Okay, hi guys. Just 1 second and then we'll get started. So I guess before we go over anything new, does anyone have questions about what we covered before? Um, okay. If not, then I guess today we're gonna take a look at this concept known as time complexity. So it's not as important for bronze, but it's a good concept to know for USACO in general. So, like, I don't know if you guys know this, but if you go to the USACO contest rules, um, USACO actually has a time limit for how long your code can run. So, like for bronze, it's not as bad because if you look at some of the problems we were doing yesterday, like daisy chains, like the maximum amount of flowers is really small. So you can do like a lot of operations and not reach this time limit. But it's still good to know what's the most amount of operations that you're actually allowed to do. Because if there's no time limit, then you could probably just brute force every problem, like simulate every single problem, and you'll probably get it right. But with the time limit, you don't have to worry about stuff like, is my code fast enough? Is my algorithm or is my solution efficient enough? You have to worry about that kind of thing. So in order to do a quick check for whether your solution will actually run in time, um, before you actually code it, because it'll be kind of annoying if you code your full solution and then just to realize that, oh, your solution is too slow. There's a concept called time complexity. Um, so hold on. So basically, as a general rule of thumb, in C++, you can run about 10 to the 8 operations in 1 second. And that's a lot, right? So let's test this out. So let's say C++. And then, so what exactly is an operation? Well, in operations, basically any of the basic things you can do, uh, adding two numbers is one operation, or subtracting numbers, or any arithmetic. Um, Inputting a number is also considered a single operation. So in order to uh execute let's say 10 to the 8 operations, we can do this. So let's have a counter, for example, and then we're gonna repeat this 10 to the 8 times. So 10 to the 8, that's 100 million. So does everyone see why this is 10 to the 8 operations? Because we have a loop that repeats this 10 to the 8 times. Or like to be simpler, like this is 2 operations, and then like that would be these would be 3 operations. So essentially what we're doing is we're just repeating this 10 to the 8 times. Does everyone get that? Okay, I assume that everyone gets that. So, and then like let's say we output the count at the end. And then if we run this, you can see that it still runs really quickly. But let's say we increase this to let's do that. And then okay, I won't get into details about what long is, but once the number goes above 10 to the 9, you're gonna want to use long instead of integer. But long's just basically an integer, but it can store larger values. So if you run this, notice that it runs really slowly. Like this is way over 2 seconds. And this is with 10 to the 10 operations. And it should like have an output like about now, I think. Because 10 to the 9 is like 1 second. Yeah. So that took a long time, right? But if you cut it down to the 10 to the 9, you find like, oh, it's still like not really that fast, but it runs faster. So basically, a general rule of thumb is your code should always have at most 10 to the 8 operations if you want to pass within the time limit. So is everyone following so far? Or does anyone have any questions? Oh, okay. Someone asked about programming languages for USACO. Okay, so last year I didn't actually teach USACO. That was another teacher, and yeah, I'm pretty sure they use Java. But actually, for bronze, you can use basically any language, like even Python. But once you get to silver or like past silver, basically the only language that you should use is C++, because the other languages are slower. Like especially Python, definitely do not use Python for USACO. It's really bad. Like outside of USACO, it's pretty good, but in the USACO context, Python is not very good. And yeah, C++ is like, uh, if we go to like contests, contest results, you can see like the majority of people are using C++, and like Java is maybe like a quarter of the people that are using C++. So yeah, I would say use C++. Does anyone else have any other questions? Okay, does high school teach Java, Python, or C++? In the high school, if you take APCS in high school, you use Java. So like, I guess in that regard, Java is like kind of useful to learn. But USACO doesn't really teach you any of those programming concepts anyways. USACO more teaches you like problem solving. But like in school, the concepts are a lot more different. Yeah, that's a good question though. APCS principal course? Not sure what that is. But like, yeah. APCS-A and APCS-DS both use Java. But like USACO and APCS or like school curriculums don't really have much in common. So like even if you're like in USACO Platinum, you might not like be able to do well in APCS. Like they're not really the same skill set. Um, well, like yeah, but the syntax for a lot of like if you know C++ well, then it's pretty easy to learn Java. Like for me, I I did like mostly C++, but then f for APCS, you needed to know Java. But like once since I knew a lot of C++, transitioning to Java was pretty simple. Like they're pretty similar languages. Okay. Does anyone have any more content questions? Or I guess any question, doesn't really matter because it is the last class. Okay, if there's no more questions, if there's no more questions, I'm gonna move on to the next topic. Um, if there's no more questions, okay, let's say instead of having this fixed number, we have like a number n, and like we input this number n, and then here we change this to n. Now, does anyone want to like say how many operations this code uses? Like notice that this here is not a fixed number anymore. It's not an easy question, but I just want to see if anyone has any guesses as to how many operations this code takes. Anyone? Well, okay. I guess we can start off with an easier question. Let's say we have I less than 10. Does anyone know how many operations this part takes? If I is less than 10? Yeah, 10 is correct. And then, so if I is less than 100, it'll take 100 operations. If I is less than like 531, that's how many operations it'll take. So if we have I less than n, how many operations should it take? Yeah, n operations, that's correct. So basically, you can see that n here is like a variable. It's not constant, like 10 or 100. It's not a constant value. So we use this concept called time complexity, which is denotes based on a certain variable, how long will the code take to execute. In our case, the variable is n, and because it takes n operations, this code will take O of n time. And then, okay, what about here? Here we have a nested for loop. So does anyone know how many operations this will take? Yeah, n squared. Very good. And it's like O of n squared time, or n times n time. And the reason is because the complexity of this loop is O of n, right? So every time we do this loop, we do n operations, and then we do those n operations n times. So in total, we do n times n operations. Okay, so what's the importance of this? Well, remember earlier when I said you can do 10 to the 8 operations in a second? Well, that means that if our code runs in O of n time, then n can go all the way up to 10 to the 8, and it can still run in 1 second. But contrary, if we have O of n squared complexity, then we have to have n times n to be less than 10 to the 8, which means that n has to be less than 10 to the 4. So we can see that if like O of n squared code runs a lot slower than O of n code. Does everyone get this so far? Anyone need further explanation? It's okay to ask. I didn't have much planned for today anyway, except like review. So feel free to ask if you're confused in any way. Okay. So here we answer the question, if we have a certain complexity, what's the largest value of n we can use, right? Or like, okay, like as a quiz, if we have O of n cubed complexity, then what's the largest value of n that we can use? Or like in other words, yeah, that's correct. So basically what we want here is we want n cubed to be less than 10 to the 8. And this translates to n is less than 10. N is less than the cube root of 10 to the 8. Or 10 to the power of 8 over 3. That is not a very big number. That is like, if we plug this into the calculator, 8 over 3. That's like not even 500. So yeah, n is much smaller here. So here we were able to do up to 10 to the 4 operations. I mean, here n was able to be up to 10 to the 4, and here n is like 500, and here n is like 10 to the 8. So you can see that time complexity makes like a really huge difference. Okay, does anyone have questions about this part? Okay, so we can see that like time complexity has a huge impact on our code. And we already figured out, given the time complexity, what's the largest value of n we're allowed to use. But the more common question is, given our n, what's the worst time complexity we're allowed to use? So like, if n is 10 to the 8, then our code can run in like O of n. And if our time complexity is like, if n is like 10 to the 4, then our code should run in at most O of n squared. And if our time like if n goes up to 500, then our code can be as bad as O of n cubed. So like let's look at some example problems, like the problems we did yesterday. So notice how the problem says n, it specifies the maximum value of n, which is n is less than or equal to 100. So if n is less than or equal to 100, does anyone want to tell me like what the worst possible time complexity you could use is? Anyone? Okay. Well, okay, I guess we can do it this way. Uh, would an O of n complexity work here? No, like O of n complexity means that it'll take like 100 operations. Does that work? Okay, what about O of n squared? Right, because 100 squared is still less than 10 to the 8. And what about O of n cubed? Yeah, it still works. And what about O of n to the 4th? Yeah, it barely works because 100 to the power of 4 is equal to 10 to the 8. And okay, what about O of n to the 5? Yeah, that wouldn't work because 100 to the 5 is equal to 10 to the 10. And that's much larger than 10 to the 8. So we conclude that the worst possible time complexity that we're allowed to use is O of n to the 4th. Now, wait, let's look back at our actual solution for this problem. Let me paste this. Let's see. So, okay, let me remove some of these comments so it's easier to read. Okay, I guess first off, does anyone want to tell me what the time complexity of this segment is? Yeah, O of n. And to be specific, it's actually 2n because you do 2 operations here, n times. But when we're discussing time complexity, we actually don't care about constants. So even if it's 2n operations or 10n operations, this is still O of n complexity. And this number right here, or this number, is actually known as the constant factor. So in some cases, if your constant factor is bad, uh, you, you might actually have less than 10 to the 8 operations. But in most cases, 10 to the 8 operations is like a good ballpark estimate. Okay. What about this part? This might be a bit tricky, but like, or in other words, how many times is this line executed? Or I guess, let's start with a simpler question. How many times is like this whole block, like everything within here, how many times is that executed? Yeah, n squared times. Because lower goes from 0 to n, and upper goes from 0 lower to n. So in reality, this would be actually n squared over 2. But again, that's a constant factor, so the complexity is O of n squared. So the below section is executed n squared times. Okay, so that means that this loop is actually repeated n squared times. So how many operations do we do inside this loop, like on the worst case? Because like notice that lower and upper are not constants. So like it's not always executed the same amount of times per loop. But like I guess on average, or like on the worst case, how many times will this statement be executed? This statement will be executed n cubed times because for this loop uh can go from as little as 0 to as much as n, right? Because lower is greater than or equal to 0 and upper is less than n. So the worst case scenario is when lower equals 0 and upper is equal to n minus 1. In this case, this loops repeats n times. So if we multiply this n by this n squared, we get that this line executes O of n cubed times. And remember that we said our worst complexity for this problem is n to the fourth, so this is still okay. And notice that here, our loop also goes from lower to upper, so this loop also repeats worst case O of n. So this segment will also execute about O of n cubed time. So in total, we have two segments that both execute on O of n cubed time. So our final complexity would technically be like O of 2 times n cubed, 2 times n cubed. But remember that constant factor doesn't matter. So our final complexity is actually still O of n cubed. And we said earlier that the worst allowed complexity was n to the fourth, so this is still valid. And we can just do a quick sanity check by plugging in n equals 100 here, and 100 to the 3 is much less than 10 to the 8. So yeah, this code runs in time. Does everyone get this part? Just type like yes if you get it. Okay, one person? Anyone else? Or anyone else that doesn't get it? It's fine either way. All right, if no one has any questions, let's look at another one of the problems we did yesterday. Oh, someone raised their hand. Yeah. Uh, Lucy, did you have a question? Or was that accidental? Oh, accident. Okay. Okay, next problem. We did this one yesterday, I think. It's shell game. So let's see. In this problem, n goes up to 100 again. But let's go back to our code from yesterday. Oh, wait, I didn't save our code from yesterday. Yikes. Okay. Does anyone remember the general idea that we used yesterday? Nope. Okay. So, uh, I'll leave the problem up for you guys to read, but I don't think I'm gonna do a refresher because we've already gone over it for 2 days. Um, so basically the solution that we used was we enumerate or we loop over every possible starting location for the pebble, and then we just simulate the game. And to simulate the game, we simulate all n turns of the game. Oh wait, wrong problem. Okay, here's the problem. So we simulate all n turns of the game, and then we do this 3 times, right? Because there's 3 possible starting locations. So immediately we know that we have 3 times n times something, number of operations. Sorry, writing with the mouse is really obnoxious. Okay. But okay, so what is this something? This something is how long it takes for us to process a single turn in the game, or how many operations we need to process 1 turn in the game. So what do you guys think this is? Remember that we kept a variable called current, which is the current shell, the pebble is under. And then for each turn, we did this check. If current equals AI, then we set current to BI, and then if current is BI, then we set current to AI. Right? We did that. And then finally we check if current equals guess I, then we want to increment our answer. So how many operations is this? This part right here. Anyone? Okay. Uh, G of I? What do you mean? Like in these 3 lines, how many operations are there? Actually, I made a typo. This should be else if. But yeah, what's the most number of operations I could execute here? Well, okay, let's look at it. If here we have an is, an if, and an else if. We know that only one of these can execute. Wait, actually, that's not entirely accurate. Making this comparison, if cur equals AI, this is actually an operation. It's like making a comparison is still an operation. So technically here, if this were true, then we would do this operation and this operation. So that would take us 2 operations. And then we would ignore this operation. But if this were false, we would still make this comparison. So that's 1 operation. And then we make this comparison. So that's 2 operations. And then we make this comparison. Oh, we make this operation. So that in total, that's 3 operations. So this segment can have actually at most 3 operations total. And then this segment can have at most 2 operations total. So 3 plus 2 is 5. So in total, there's actually 5 operations that execute here. And okay, so our final complexity is 3 times n times 5. That would be 15n. But again, we can just drop the constant factor. So our final complexity is just O of n. And that means like here, instead of 100, n could probably actually go up to like 10 to like the 8 or 10 to the 7. And this problem would still be very easy to pass. So does everyone get this part so far? Or does anyone want further clarifications? I'll leave this up for like 2 more minutes in case you guys have questions. Okay, no more questions. We'll go over the last problem we did yesterday and review the time complexity of that. So I believe it was diamond collector. Let me log in real quick. Okay. So Here we have n is less than or equal to 1000. So does anyone want to tell me like the worst time complexity that we could use? Anyone? What's the worst possible time complexity that we could use for this problem? Or like we could do it this way again. 10,000. Uh, Derek, what do you mean by that? Like if n, like what I'm asking is like if n is 1000, then like will O of n work? Oh, sorry. If n is 1000, will O of n work? Yeah. And then will O of n squared work? Yeah. But O of n cubed will not work, right? Yeah. So essentially, that means that the worst possible complexity that we're allowed to use is O of n squared. You get that? Okay. And like the question now is like sometimes when you think about these problems, the time complexity is actually like a big hint. Like, what does an O of n squared time complexity mean? Well, here we have that basically an O of n squared time complexity most likely means that we have a loop that goes from 1 to n. And then inside that, we have another loop that goes from 1 to n again. So it's like a pretty big hint to the problem because this basically suggests for the problem that we should do one pass. We should process every diamond. And then for each diamond, we should compare it to the rest of the diamonds and do something with that. That's what this complexity suggests. And if any of you guys remember our solution from yesterday, that's actually exactly what we did. So if you guys remember, last time what we did is we looped over every diamond and fixed that as the smallest diamond in our case. So like while we're processing diamond one, we're like, okay, the smallest diamond in our case will have size 1. And then what's the largest size? What's the largest possible size of this case? And then in this particular situation, we can include 4, 3, and 1 because these all have difference less than or equal to 3 to 1. So what so and then after we finish processing the answer for 1, we go to 6, then we go to 4, we go to 3, we go to 1. So like that consists of the outer loop. And then once we fix our smallest value, we have to loop over every single diamond again, right? to see if we can actually fit it in this current case. So that consists of the inner loop. So like even without writing the code, you can tell that the complexity of this solution will be O of n squared. And we know this is satisfactory for the problem. So yeah, that's how you can verify like whether your solution is actually valid before you code it up. Because like especially in higher levels, you do not want to like accidentally get a wrong solution and then spend like 30 minutes coding it and then another 30 minutes debugging it just to find out that it's wrong. Like you definitely don't want that. So, any questions about this problem? I know like time complexity is not a really easy concept to understand. So like any questions would be fine. Um, if no questions, I have thanks. Thank you. For any of you guys that are more interested in this in USACO bronze, I have a challenge problem for you guys. So, feel free to work on that if you want. Thank you. Thank you. I hope you learned some things too. Okay. So yeah, that's a challenge problem. If you have any questions about that problem, feel free to email me at this email address and I'll try to get back to you. But if no other questions, we can end class for today. Thank you guys.